3 p.m. right here in Hilversum with the sun soaring high above the clouds. Looks like a warm, humid day today with a few breezes from the west. I'm joined alongside Mr. Sharma today, here to discuss the common drugs marijuana and alcohol. Hello, Dr. Sharma. How's it going?
All fine here, and you, Mr. Iksani?
Yes, all good, thanks. Now tell us, Dr. Sharma, what exactly is marijuana?
Marijuana is a combination of stems, shredded leaves, and flower buds of the cannabis sativa plant. Marijuana has many uses as it can be eaten, smoked, vaporized, brewed, and sometimes even taken topically. However, most people prefer to smoke it.
Wait, you mentioned a plant?
Yes, of course. It is one of the many reasons why it's considered so common. I mean, you can see it grown in someone's backyard sometimes, though it is absolutely illegal. The government spends a lot of time suppressing the revolt against the illegality of the drug, though I will discuss this more in depth after, of course.
Could you tell us a bit more about its properties and what makes people actually take it?
The main psychoactive or the mind-altering asset chemical in marijuana that is responsible for most of the intoxicating and pleasuring effects that people seek is called delta-9 tetrahydrocannabinol, most commonly known as THC. This chemical is found in resin, which is produced by the leaves and buds that are primarily part of the female cannabis plant. According to a research conducted by the Potency Monitoring Project, the average THC content as marijuana has increased from less than 1% in 1972 to 3 to 4% in the 1990s, to nearly 13% in 2010.
Oh, right. So the psychoactive drug is delta-9 tetrahydrocannabinol, THC. How exactly does it work, though, in the brain and the body?
After you inhale the marijuana smoke, its chemicals start to zip throughout the body. This is because THC is an extremely potent chemical when compared to other psychoactive drugs. Once it is in your bloodstream, THC typically manages to reach the brain in seconds after it is inhaled or intaken and begins to work. The cannabinoid receptors immediately are activated by neurotransmitters called anandamide. Similar to THC, anandamide is a cannabinoid. However, one that your body makes naturally. The THC actually mimics the actions of anandamide, which means that THC binds with the cannabinoid receptors, hence activating neurons, causing adverse effects on the body and mind. The high concentration of cannabinoid receptors actually exist in the hippocampus, basal ganglia, and the cerebellum. The hippocampus is placed within the temporal lobe and is extremely important for short-term memory retention. When the THC starts binding with the cannabinoid receptors in the hippocampus, it works by interfering with the recollection of any recent events that the person has experienced. THC also highly affects coordination that the cerebellum has control over. The basal ganglia is in control of the unconscious muscle movements, which is also another reason why motor coordination is impaired or affected when one is under the influence of marijuana.
Wow, interesting how the chemical THC actually works through the receptors and the neurotransmitters. Though, how does this actually feel for the person?
Users often describe the experience of smoking marijuana as initially relaxing and mellow, which creates a feeling of lightheadedness and haziness. However, these feelings may differ depending on specific strain.
Oh, okay. But what effect does it actually have on the central nervous system itself? Any therapeutical, societal, or legal consequences?
The psychological stimulatory effect is widely recognized. The molecular and biochemical components are seen to interact with CB1 and CB2 endocannabinoid system receptors in various parts of the central nervous system structures, CNS, and the immune system present. Delta-9 tetrahydrocannabinol, THC, the psychoactive element can be reproduced synthetically. Systematic studies show evidence of the therapeutic effectiveness of marijuana only for specific symptoms of multiple cases of sclerosis, spasms, spasticity, and pain, regardless of its attempt, including childhood epilepsy. Evidence from studies indicate that the significant effects of smoked marijuana on the functioning, structure, and brain connectivity. The cannabis intake during pregnancy impacts the fetal brain development and potentially leads to later behavioral problems in children. Advanced imaging and neuropsychological test techniques show that there is hindrance in learning process in adolescents with substance use. Moreover, marijuana also increases the cognitive impairment in patients who are diagnosed with multiple sclerosis. The ethical and social consequences to legally free marijuana for recreational use may be difficult. The medicinal or psychoactive cannabinol shows no addictive effect, however, does require controlled efficacy and safety before any use.
Wow, so there's several implications on the therapeutic, societal, as well as legal aspects. Though, how safe is marijuana actually?
Absolutely. Marijuana is considered one of the safest, if not the safest drug out there. There are many organizations set up for making it legal, as it proves to be far less dangerous than alcohol, heroin, and any other drug. Where the problem actually arrives is in the teenage areas. When the intake of marijuana is begun in the teen years, it can have a significant impact on the brain development. This includes decreased brain activity and fewer neural fibers in specific areas, and a hippocampus that is actually smaller than average, which controls the memory functions and learning. According to an important study in 2014 Northwestern Medicine study of teen marijuana users, the structures related to memory in the brain appeared to shrink drastically and showed possible signs of a decreased neurons. However, these abnormalities in the brain remain 2 years after the teen stopped using marijuana, which highly indicates that the drug does have long-term effects and makes the brain similar to brains of schizophrenics.
But does it mean it could be legalized? I mean, what impact does it have on the health?
Yes, I highly think it will at some point. The Guardian shows an article that many states around the country, more than 20 in total, have officially legalized medical marijuana. According to a study that was published in Journal of the American Medical Association in January 2012, it is seen that marijuana does not actually impair any lung function and is even shown to increase lung capacity. Marijuana can actually prevent epileptic seizures, shown by a 2000 study by Robert J. DiLorenzo of Virginia Commonwealth University, who gave marijuana and synthetic marijuana to epileptic rats. The drug got rid of the seizures of the rats for about 10 hours. Cannabinoids that are active ingredients in the marijuana, tetrahydrocannabinol, also known as THC, are shown to control seizures by binding to the brain cells that are responsible for controlling the excitability and regulating relaxation. In another important study in 2010, researchers at Harvard Medical School suggested that some of the drug's benefits can actually be reduced anxiety, which would highly improve the smoker's mood, acting as a sedative in low doses.
So, after evaluating the implications, does this mean that marijuana has less of an impact on the overall health, Mr. Sharma?
Yes, but when using it in a decent and moderate amount. Marijuana does have negative consequences even to adults. However, it is to what extent is what differs it to other drugs.
Ah, so I see that there are many positives to marijuana. So am I to say it is safer?
Correct, but this is only the case if used in moderate amounts or medically. In conclusion, I can say that marijuana is an extremely safe drug when compared to any other drug out there. Although it has many negative effects, it can be said that the positive totally outweigh the cons. I think that marijuana is a much safer drug than alcohol, as it will be discussed by you later in this podcast. Thank you. And that's about it for marijuana. Say, Mr. Jiksani, what precisely is alcohol? Is it considered a drug as well?
Good question. Well, alcohol, just like marijuana, is a common drug used by many around the world. It is consumed in a liquid state and is found in many beverages and foods, including wine, beer, and even in some chocolate.
Wow, that's pretty interesting that it can be found in such simple foods like chocolate, yet be considered a drug.
Sure is. It can also be referred to as a depressant, signifying that it slows down the vital functions of the CNS, the central nervous system. However, this is only when it's taken at high doses. When taken at low doses, on the other hand, alcohol can be called a stimulant, meaning that it causes chatty and social behavior, as a result of an increase in brain and psychological activity in general. Though this may seem okay at first, it can lead to drowsiness, respiratory depression, where breathing becomes slow, shallow, or stops entirely, coma, or even death.
Oh my, this means you really have to be careful about how much alcohol you consume. Though, who consumes it actually? Are there any age restrictions?
Indeed, actually, there are various laws all over the world with restrictions on the consumption and the purchase of alcohol. Here in the Netherlands, however, the purchase and consumption ages are both set at 18 years old, after being raised from 16 years old in 2014. It is often consumed at parties by teenagers and the youth in the form of beer and shots, while it is commonly consumed by adults and seniors in the form of wine at formal occasions.
Oh, okay. So that means quite a large range of ages consume it. Interesting. Though I was wondering, what are some of its chemical and general properties, and what exactly makes it so addictive?
Well, consumable alcohol, also known as ethanol, has a chemical formula of C2H6O and is a liquid at room temperature with a boiling point of 78.5 degrees Celsius and a melting point of minus 144.1 degrees Celsius. It is mildly acidic with a pH of around 4. What makes it so addictive though, you ask? Well, this is quite challenging to explain, though I'll try my best. You see, alcohol isn't itself that addictive actually. It's more the chemical reactions that occur inside the brain as a result of alcohol that make it so addictive. Essentially, our bodies contain minuscule chemicals called neurotransmitters, which transmit messages to and fro nerve cells, instructing our body on what actions to perform.
But wait, are there several forms of neurotransmitters?
Indeed there are, the two primary types being inhibitory and excitatory. The function of inhibitory neurotransmitters is to calm and ease the brain, while the excitatory neurotransmitters have an opposing function of stimulating the brain, allowing for focus, attention, and other functions that require higher than resting brain activity. Alcohol has a distinct effect on both of these types of neurotransmitters, specifically known as gamma-aminobutyric acid, GABA, and glutamate. GABA, an inhibitory neurotransmitter, is responsible for reducing excitability in the brain. It calms it down in a sense. However, the consumption of alcohol leads to an increase in production of GABA, resulting in an immense inhibition of the brain. This eventually leads to the several known side effects that alcohol commonly has, such as having difficulty to walk, to talk, and short-term memory loss.
What effect does it have on the other type of neurotransmitter?
Well, the effect of alcohol on both these types of neurotransmitters are actually closely linked. A regular consumption of alcohol forces the brain to get habituated to this increase in GABA. As a consequence, it produces an increasing amount of glutamate, an excitatory neurotransmitter, in order to remain in a state of homeostasis or chemical equilibrium. This in turn causes a rapid increase in brain activity, essentially opposing the effects of the increased GABA. This is what causes resistance to alcohol, meaning that it would take more alcohol for the same effects to be observed.
Okay. I heard it has an effect on dopamine too. Could you explain that?
Sure thing. Dopamine can be regarded as a reward hormone, as it is produced in high quantities when we experience pleasure and delight. In short, alcohol tricks the brain in the sense that the initial effects of alcohol are pleasurable. Therefore, the brain considers alcohol use to be rewarding and reinforces this by releasing dopamine. Though this may not seem bad at first, this causes the brain's dopamine transporter and receptor sites to get overused as a consequence of long-term drinking. This was recently confirmed by a study conducted by a German psychiatric center. They found that, quote, prolonged alcohol abuse will ultimately interfere with the brain's ability to use dopamine and subsequently inhibit the individual's ability to feel pleasure.
Just for all our alcohol beverage lovers out there, could you briefly explain how it is made?
Alcohol can actually be made in two ways, by a biological process referred to as fermentation, and the hydration of ethene, the chemical way. With fermentation, alcohol is made from glucose, separated with yeast, forming the products ethanol, carbon dioxide, and energy, and is therefore exothermic. Hydrating ethene involves adding water to it, causing what they call in chemistry an addition reaction, and the production of ethanol.
Fair enough. Now, are there any economic implications to alcohol? How has it affected the economy as a whole?
The economy has been impacted quite significantly by alcohol, both directly and indirectly, producing positive and negative effects. A positive implication that alcohol has had on the economy is that the overall alcoholic industry has proved just below $25 billion in the United States alone, according to the Distilled Spirits Council. This is a tremendous number, and from this number alone it can be deducted that the alcohol industry makes a large part of the US economy.
What about negatives then?
Of course, there's also a lot of negatives that alcohol has on the economy. A few negatives include less productivity from work-related absences, high medical and public care services, and finally, high costs relating to individuals and households. According to the Institute of Alcohol Studies, A total of £7.3 billion has been lost due to unproductiveness, accidents, and absences from work, all due to alcohol in the UK. This is because less work is being completed in longer periods of time, resulting in less overall revenue made. Furthermore, another statistical piece of research from the Institute of Alcohol Studies found that an approximate amount of £3.2 billion costs are made to public health and care services. Another study by Green Facts stated that workers with drinking problems are nearly 3 times more likely than others to have injury-related absences from work. This is all due to the fact that drunk people that drive, for instance, put themselves and others at risk, as alcohol has been proven to increase reaction time and decrease awareness on the road, leading to more accidents and afflictions. Although alcohol has had its positive and negative implications upon the economy, I do strongly believe that the economic negatives outweigh the positives, since work productivity is decreased and higher healthcare and individual and household costs are produced in the long term. Thanks for tuning in into another drug showcase, this week's feature of marijuana and alcohol. Catch us next week when we'll be discussing the drugs ecstasy and tobacco. And that's all from us here at the center. Now back to Michelle with some traffic information.